I'm Leo. Today I'm going to talk about the challenges for NLP in social platforms. And as Mackenzie said, I recently actually joined Grammarly 2 months ago. It's been super fascinating ride so far. And a lot of the work I'm going to talk about is about my previous career. I worked in several companies that deal with social platform data. I've done research in data on Twitter, Reddit. So there's a lot of different problems that I faced in the last, 10, 15 years I've been working on this. And the goal of this talk is not necessarily to give you answers, but actually to raise questions and make sure that people that are working on social platform data are aware that those things matter and that they can influence your models. And especially the biggest takeaway I want people to have is that communication, especially the ones in social platforms, are not only about the text itself, but about the entire context that surrounds people when they are communicating. And that counts as where you are, who we're talking to, and as we're going to explore several other factors, even like weather, where you are. Right, so have a short agenda here. I'm going to talk a little bit about the challenges I've seen, and I'm going to focus mostly on 4 different kinds of challenges. The informal language in low context, how that affects your models, how language evolves and how that's a problem, but also interesting opportunity for us to do research. Talk about a little bit of data annotation and multilingual and multicultural settings and the challenges that come from those things. Okay, at the end of each one of those blocks, I'm going to stop. And if you have questions, I'll try to answer the questions that you submitted on the QA. So please send them throughout the talk, and I'll stop and answer them. Okay, so talking about the biggest difference between formal and informal text, right? And when I say informal text, I'm talking about social media text. Thinking about existing benchmarks, right? If you're familiar with the task of name identity recognition, it is a task where, given a piece of text or string, you want to detect if each one of those tokens that you have on that string are an entity. And by entity, I mean like a person, a location, organization. And your model basically, for each one of the tokens that you have, is going to output a label with the entity type that you find, right? And there's a lot of work being done on this. You're going to see entity recognition a lot on this presentation because that's a problem I worked a lot over the time. But if you look at this plot from the Econo dataset, which is a very famous benchmark for like formal text and for entity recognition, you can see there's a lot of submissions. This is from Papers with Code, where people submit their best results from their papers. And you can see that the numbers we see here is very high. They're very close to 100%. And honestly, there are even papers that have examined that gap from 94, 95 accuracy or F1 score to 100. And they actually blame the annotation process of mistakes on annotation, the kind of ambiguity of entities. So basically, we can even claim by just looking at this specific data point, right, this benchmark, that we're very close to solving the problem, right? And we're very close to being human level, getting human level results on this, which is not true, right? This is a benchmark that people have been working on for a long time. And also that's pre-formal and kind of more Wikipedia-like data set. If we move to a different benchmark, also on entity recognition, but this one is the WNUT 2017, which is focused on Twitter data. We can see that the accuracy and F1 scores that we're getting here are much lower, on the 60s, on the best results so far. And that happens because this difference in domains is very challenging. And that makes this is the kind of real world problems that a lot of people are facing when they work in social media data nowadays. And there's so much room for improvement yet, and so much things that we could be doing. So that's not only true for entity recognition. A couple of years ago, I worked on this paper called Twitterval, where we realized that people were starting to think that a lot of those problems were solved. So we created a benchmark on Twitter data with a lot of the core tasks that people were already working on. And we trained several models, created baselines, mainly to explain what is out there, what are kind of the problems that people are working on. And how good can we get with the state-of-the-art models back then, like Roberta base or Roberta large models in a couple of years ago. And if you look at the average, like, of course, like the stronger models are getting slightly better performance, but the average, the result that we can get from those models, even the ones fine-tuned on the data and trained on Twitter data and so on, still much lower than the 90s metrics that we're seeing for formal text on previous data set. So that kind of shows that it's a very challenging scenario compared to the Kano data set. And a lot of the tasks that we had, like Glue and Wikipedia articles, news articles, and so on. And one other fascinating thing we learned on this project is it is a challenging problem, but when we released the models, like all those baseline models on Hugging Face, we saw this like surprising result where our model, the top one, the Twitter sentiment model there, actually became the most downloaded model on Hugging Face for a couple of months, occurring over 15 million downloads in a single month and surpassing GPT-2 and BERT, which has always been the most downloaded models there. Which shows that it is a hard problem, but also that a lot of people care about it. And we should kind of engage the academic community to push this forward and make sure that people have the tools that they need to actually explore harder and harder problems in social platform data. So we continue partnering with Cardiff University, where we created a Tweet NLP. It's a paper we presented last year at MNLP, where we created this library and this UI where you can play around with different tasks like sentiment analysis, hashtag analysis, hate speech detection, and recognition, all on Twitter data. And that allows for people to understand limitations, allow for them to incorporate those models into their tasks. And that actually encourages people to keep working more on this direction. That's a very hard problem, as I said, and we need as many people as possible involved in this to kind of push the state of the art forward as fast as possible. Also, our paper, this is an old screenshot. I think it's more citations than I'm showing here right now. But the paper that I just mentioned before just got hundreds of citations, which means people actually are using not only the models that they're downloading, but they're also using the benchmark, and they're actually pursuing research in that direction. And hopefully those tools can help people out. Another important factor of NLP in social platforms is that social media is kind of a proxy of society most of the time. People talk about the events that are happening. They talk about the kind of their opinions. Celebrities like presidents go there and they share their information. So there's a lot of things going on that can not only be interesting from the NLP perspective, but from the social sciences perspective, like computational social science, or from the social network analysis perspective. There's a lot going on there. And that actually makes it interesting because several tasks, differently than formal tasks, or there's very standard tasks that people usually care about. There's a lot of emerging tasks in social platform data, which kind of comes from the questions you want to answer from society. And recently we released this Twitter topic classification at Coling last year, which is kind of the topics that people care about on Twitter. Can we kind of detect if certain tweets are about this topic, or even STEM about this year during ACL, we're going to be hosting the one of the tasks there for multilingual intimacy analysis, which is kind of also a very non-standard task that we've seen there. So the key point here is if we have people trying to answer different questions, you can come up with your own tasks as long as you can label your data. And most of the time, people are very excited to engage with those. Okay, I think there's a question here. What kind of data sets? I'm not sure I understand the question, but can be considered from benchmark. I feel depends on as I mentioned, just the emerging tasks, right? Like I feel the benchmarks should be the tasks that most people are excited about in social media and seeing how our models can perform there. Like if it's a lot of the benchmarks nowadays are trying to, for example, super glue, they're trying to push go one step further on like the formal text, and the same thing could apply for informal text benchmarks, like trying to figure out like rare entities that you might find on Twitter. The topic classification is one is tricky, right? Because even if you're thinking about topics like politics, it could shift. Like Donald Trump was a celebrity. If you're using the topics that we showed before, it became a president. Now he's an ex-president that's still engaged in politics. So even the topics, if you're not careful, like those can change and can be tricky to detect depending on context. I hope I answered your question. We can talk more about on that later. But so the first challenge I want to talk about is the challenge of informal language and low context. And that's very related to this difference between like formal and informal text, because when you're working in formal text, like Wikipedia, news articles, you have paragraphs of context for your models. When you're working with books, right, you have pages of context. But when you're working on social media data, you might have something like that, right? Like a very small string which has typos, acronyms, misspellings, emojis, GIFs, non-standard capitalization. So for our models to learn those nuances, it's already pretty tricky. Now imagine you're working on a project like the one I worked a couple of years ago. So I mentioned entity recognition, which is detecting if, like, for example, Justin here is a person. But the next step after you do that is what we call entity linking. So basically, let's say you have a database of a lot of famous Justins that you care about. Justin Trudeau, Justin Timberlake. And you want to know if that Justin, specific one on the text document you have, is one of the Justins you have in your database. So we can call that entity linking, entity disambiguation. And if you look at this specific piece of text, it's literally impossible to know what we're talking about. Of course, we don't care if it's your friend Justin. Of course, you might care, but like in general, when you're doing research, we care more about those entities that would be on the databases. And once I started working on this project, I started thinking, well, what's the best way for us to do that? And looking at all the context that's available, like all the variables that we could be explored from a social media perspective, I started exploring, right? Like, so let's say we have weather available. Let's say it's cloudy when someone posted that. Not very helpful, right? Doesn't matter, rain or shine, Justin might be a person, the same person. Let's say this was taken Saturday night. And Saturday night kind of narrows down a little bit. Maybe you're not talking about Justin Trudeau necessarily. I know some people are very excited about politics, but usually Saturday night is not the time that people talk the most about politics. So we're kind of narrowing down to someone that's like, I don't know, Justin Timberlake, if you're listening to their song on the radio or something like that. Let's say that we know the location of this post, and this post was taken on Hollywood Bowl, which is a concert venue in Los Angeles. And now that narrows down even more, because it's very likely that this Justin is kind of Justin Timberlake or Justin Bieber or some artist that will be performing in Hollywood Bowl. And by looking at the image, which is a very important modality here, because most like social media posts nowadays are becoming extremely multimodal. If you think about TikTok, Instagram, Snapchat, they all have images or videos associated to it. You can see that it's a concert. Okay, so narrowing down and all those modalities are kind of, and modalities and contextual informations are helping. And it can even go a step forward and kind of mix those things and look at all the posts that happen around the same time and location as that post. And if you do that, you might see that while this specific post is only saying Justin and makes it very hard to understand which Justin, other posts around it might be talking about Justin Bieber, spelling out. And now it's much more clear that Justin Bieber, like that this Justin is very likely to be Justin Bieber based on the image, definitely shorter than Justin Timberlake, and the spelling from the other posts. So I got fascinated about this idea of going beyond text and incorporating context. And the first approach I had for a couple of years was to try to incorporate images into it. And back then, like, yes, images help, but not a lot. And maybe it's not worth pursuing this. What was not worth, maybe nowadays with the new models, we might want to revisit that. But it was not worth pursuing it because of the cost of analyzing the images and the benefits it would bring to some of the models that we had. But one thing we learned from this is images did help. And the interesting fact was, but not always. But not always part is you might talk about Justin Bieber and take a selfie, right? And then your selfie doesn't really help what you're trying to convey. It's kind of creating noise to your model. So coming up with a way to reweight your inputs was something that really helped, not only for images, for the other projects we're going to talk about. So we came up with this idea of modality attention, but you can think of a lot of various ways of doing that. But the key takeaway is that when you add contextual variables, think about the previous example, right? We have the weather. The way we incorporate it and their importance on each one of the examples might change depending on your specific instance you're trying to make a prediction. So you should be careful about that and figure out ways that you can rebalance and make your model learn when each one of those inputs are important to your model. And the way you represent the variables matter a lot. Another project that we worked on, we call Sunshine with a Chance of Smiles, was basically trying to incorporate weather into like sentiment analysis models. And the key idea here, well, if you're familiar with sentiment analysis, the standard approach for this is basically you get an input string and you predict if that is a positive, neutral, or negative sentiment that's being conveyed on that string. And in this case, beach day, some people, it's kind of a subjective task. So some people might think it's positive, some people might think it's neutral. If you don't like the beach, you might think it's negative. It might be ironic as well. So how just with the text itself, it's very hard for our model to make a decision here, right? So we started exploring, okay, is there situations where the weather could help clarify, but not only weather, but like all the context, location, time that you were immersed. And let's say that now you know that you have the string. This was posted in Los Angeles on a Saturday, and right now it's sunny. It was raining the last couple of days, like it actually has been in Los Angeles. So now you know that the person, it was raining, now it's sunny. They can go to the beach because they don't have to go to work. And you're in a place that there's a beach, then much more likely that we're talking about a positive sentiment here, right? And I think learning from the findings that we got from the image multimodal task I just talked about, I think this helped to think about how to incorporate the context. Because the first idea we had was just to have weather as a variable, and it didn't help that much. It helped a little bit. But the moment where we started looking at this change in weather, like instead of having just that it's sunny, but actually that it wasn't sunny before and it's sunny now, or that the difference in temperature has increased or decreased a lot in the last couple of days or weeks, we start seeing a stronger pattern, and that actually started helping the model much more by doing that. So basically, what we found is that if it's much colder or much warmer, people get more negative sentiment. And I'm not talking about only posts that are talking about the weather, but in general, people's posts are more negative in general when they are unhappy with the weather. And that's kind of fascinating, right? Also, there are other factors that can influence the weather, not as the sentiment, not necessarily because of the time of the day or the day itself, but mainly about the topics that people talk about during the day and during the week. So we found that people are much happier during the weekends than their weekdays, at least on their presented sentiment. I guess people prefer partying than talking about their work or going to the gym. And this became, this is a factor that it's definitely worth controlling. And when I say worth controlling, it's very hard for you to completely mitigate the effect of those factors in your data set. But one thing to keep in mind is when you're labeling data, you probably want to distribute your data annotated from different time frames, like from different days of the week, different months of the year. There's a cool talk from Google on a previous Grace Hopper conference where they talk about creating their autocomplete for Gmail. And basically their initial approach was to gather data, and they got data only from November. And basically what happened to the model is instead of saying hi or dear someone on the beginning of the email, to always say Happy Thanksgiving, which I thought it was very funny, but also kind of always reminds me that we should be careful about gathering our data. It's almost impossible if you don't have the control over the entire data set to control for all those factors, but it is important to know that those things can influence your data set and your task, either through the variables you want to incorporate into your model or the way you annotate your data and kind of sample your data as well, right? And that's a good segue for this ever-evolving and how dynamic language actually affects our models. But I'm going to take a break here if there's any questions. I don't see any questions here. So I'll continue, but again, at each one of those segments, I'm going to go back to the QA. If you have any questions, happy to answer them. So next up, we're talking about how people, depending on the time of the day or the time of the year, they talk about different topics. And this evolution of language, of how language is dynamic and influenced by time, something that I've been focusing on a lot in the last couple of years. And I'll start with this, which I call the curious state of the volleyball emoji. But basically, back then we were analyzing how people are using different emojis through time. And if you look at this graph here, you're going to see that on the y-axis is a normalized frequency of how much people are using the volleyball emoji. The x-axis is time. And you can see that the use of the volleyball emoji was pretty stable during the years. But there's two specific peaks that caught our attention. The first one was pretty obvious. It was during the volleyball World Cup in China. People were talking about volleyball, and they are using the volleyball emoji to represent volleyball. Very expected. The interesting one was the second one, which happened in March of 2020, just a couple of days or weeks after the lockdown started in the US. So that meant no one at all was playing volleyball, right? People were afraid of getting out of their homes. Why would people be talking about volleyball? Does anyone have any idea of what this could have been? Please feel free to share in the chat. People are shy today, but video games. No video games. That would be an interesting guess, though. Anyone else? Anyway, also no. Shape of COVID. I like all those guesses, but actually no. And we tried, we had to dig deeper to actually understand what was going on there. And we realized that peak actually happened at the same time that Tom Hanks got COVID. And Tom Hanks back then was traveling to Australia with his wife, Rita Wilson. And they both kind of had to quarantine in Australia. And the internet kind of figured this out, and they realized that's not the first time that Tom Hanks was stuck on an island with Wilson. Basically, if you watch the movie Castaway, Tom Hanks is character, of course, is flying on this plane, the plane crashes, he gets stranded on this island, and his only friend is his volleyball, which he calls Wilson. And that's basically what people are alluding to, that first, the name of his wife and the name of the volleyball were the same in the situation, and they are using the volleyball emoji to talk about Wilson here. And I feel as an NLP practitioner, this is fascinating and terrifying at the same time, right? Because fascinating because it tells how language patterns can explain a lot about society and can kind of tell us what's going on. Terrifying because now our models are completely exposed to this kind of things, and they're going to break. There's no way, or very few ways that we know nowadays to actually address this problem. And there are definitely some ways that you can incorporate. And one of those ways, it's becoming increasingly popular with all the large language models, is those non-parametric approaches where you have a database and at inference time, you kind of query those specific instances. For example, on this paper that we had last year of animated recognition Twitter, for entity recognition, we would query all the tweets that happened around the same time. Same idea of the Justin Bieber example I gave. And then we would use that to improve the models by using multiple tweets instead of a single one. And the takeaway here is that people do communicate differently based on events, right? And if you flip it around, which is even more fascinating to me, is that during the events, there are change, but also events change how people communicate over time and their conception of the world as well. So another paper that we had called Time Alarms, we got 2 years of data, like millions and millions of tweets. We broke it down to quarters. And we trained on each one of those scores of millions of tweets, we trained a masked language model. And if you're not familiar with that, masked language model is when you get a lot of unlabeled data, you randomly select tokens on that data to mask, like I'm showing in this example on the top here. And the goal of your model is try to predict which word is missing there. So we trained one model on each one of those quarters. And if you look at the example like this one, so glad I'm masked vaccinated. If you ask each one of those models to make a prediction here, you're going to see that the top words being predicted are going to shift over time. And this kind of shows a lot how the world behaved during the entire COVID pandemic. Basically, if you look at the very beginning, just the very beginning of the pandemic, the top word that those models be predicting is the word not, because of anti-vax discussions in Twitter, because there was no vaccine. People mainly would be glad that they were not vaccinated. But as the vaccine started becoming more popular and accessible, the word getting vaccinated became the top one. And then over time, as the second shot became accessible, the word fully became, well, we thought we only needed 2 shots, right? But that doesn't matter, like based on the perspective of people back then, the word fully became the top one. So you can see by looking at how language changed over time, that the perspective of society, at least what they're sharing social platform data, became like different. And this is very interesting to explore. The University of Cardiff continues to release those models every three months. So if you're interested, all of those models are Hugging Face. If you want to do like test, like how, like on one of your projects, you want to test how those different models behave on your data sets, go for it. And if you're very interested in this topic, last year we also organized the EVO-NLP workshop, the first workshop on ever-evolving NLP, which a lot of very smart folks submitted work. And there's so much there that I learned from. So if you wanna engage with this, please go there, check the existing work. And also probably there are gonna be a second workshop on ever-evolving NLP. Feel free to submit to that as well. Okay, and that's a good segue to the next step. But any questions so far about the evolution of language? I know these previous examples were very different than what people usually say about the evolution of language, right? Like several papers look at 20 years of data and see how the semantics of words change over time. The truth is, in social media data, those 20 years happen in 2 weeks, right? You have a new influencer that didn't exist last week. Now it's the most important thing of a lot of people's lives. And then in 2 weeks, they're not going to exist anymore, right? And then if you actually want your model to perform optimal, you have to take care of that. And data annotation is one way to mitigate. We talked about the knowledge augmentation on the answer recognition, but another approach that you could do is just basically keep retraining your models. That's an expensive approach, but that's usually the approach that people take. There are some issues there of catastrophic forgetting that are not that related to this, so I'm going to skip for now. But if active learning has definitely been a core component of keeping your models up to date, not only on this scenario, but in general, right? And mitigating this kind of temporal drift, which how people usually call this problem. And one approach we had before, still coming from the time and changes in language, was to use that in our favor. So let's think about the word corona, right? In 2019, corona was mainly used as a beer. Then in 2020, 2021, beginning of 2022, people were mainly focusing about the virus. They're not going out as much. They're probably not drinking the beer as much. So there was a shift on the distribution of how people are using the word corona. As we recover from the pandemic, and hopefully we'd never go back to that again, it's kind of a mix, right? People are still talking about COVID. They're talking about the beer. And the distribution kind of oscillated so much over time that definitely models needed to be retrained. And we came up with a very simple idea. Basically, let's just use counts, right? A lot of the times you have millions and millions of instances, and actually having sophisticated approaches is not feasible. So the approach was basically looking at previous data sets we annotated for our models, and then getting this bunch of unlabeled data that we are going to annotate, and basically counting how often each one of the tokens happened, normalized for the size of the data set, of course, happened on the previous data set that you had, how often they happen in the new one, and you basically get the ones that change it the most over time. So if the usage of Corona oscillated the most from one time to the other, you can actually pick those documents that have the most words that changed over time, and then you basically label them based on that. And by doing that, we actually saw huge increases just by annotating a little bit of data. We got to very good performance compared to just randomly annotating data. And that is a very simple approach. Everyone can just write a Python script that does that for you if you don't have a lot of data. I definitely recommend always trying to think of ways of being smart about the data you annotate, because it's a very expensive process, especially if you annotate very frequently. Okay, another approach that we worked on was to do some style transfer. So there's a lot of existing benchmarks on formal text, not a lot on informal. So for entity recognition, as I mentioned, there are some on Twitter, but not a lot. But there's a lot of them in formal text. So the first step was to learn to do a style transfer between formal text and informal text. And then from there, you can generate, based on the benchmarks that you have, you can generate versions of those benchmarks that are in social media data by setting up some constraints of fluency, consistency, and so on. And then you can generate much more data for your application when you don't have a lot of social media data. That actually is better than either training the two, like just combining the two data sets, or just training on in-domain data. We tried a lot of different approaches of training first on formal and then fine-tuning on informal. All those things were worse than generating a lot of new variations of the existing data sets in the in-domain data. So I think this is worth exploring. There's a lot more to be done here, but people have been interested in doing that. And again, context. That's the third way that I feel we should be creative about annotating. By now, you figured out that I love context, right? So a couple of years ago, I worked on this problem of language identification. If you're not familiar with this, it's a very straightforward one. You have a piece of text. You want to know which language it was written on. So if you have hola chicos, you want to say it's Spanish, bom dia amigos, Portuguese. I'm going to stop here because I only speak 3 languages, and those are it. But that's actually one of the challenges, right, of working on this task. For example, if you need to annotate, let's say that you have models like fast text, right, which supports 170 languages. No one knows 170 languages. So if you give you a random piece of text of a language you don't speak, how can you annotate? You don't really know which language that is, right? If you what people usually do on like more formal text, they usually use the hyperlinks for web pages, because there's the suffix there that can tell where it comes from, uses people's keyboard information. There's a lot of things that you can do, but those are not always available for folks, and they're usually more accessible for like formal text. Another challenge that we had there is that all the open source solutions, even the ones that are not really open source for like proprietary APIs, they're not great for short text. And we really needed a solution that would work for short text. So I don't have a paper on that. We do have a patent though, where we try to be creative, right, as I said, and use context. The first approach we did was training a binary detector for English. So that's easy, right? If you speak English, you can tell what's English, what's not English. Then we labeled, I don't know, 10,000 instances of that, and we trained the English detector model. And then we came up with hypotheses of when could we use time and location as a proxy for how people are going to be talking, which languages they're going to be using. And what we came up with is that during national holidays in certain countries, if you go to the country capital, if you actually have access to where, like city level, where this tweet came from, you should be able to know, like people are mostly going to be talking about the holidays, so mostly going to be using English because they're tourists and visiting, or not. If they're not English, they're going to be using the language of that specific country, right? So let's say we're in France during Bastille Day, and we analyze the data. We hire someone that spoke French, English, and could tell like if something was French, English, or something else. And what we learn is, yes, it's not perfect. It's a hypothesis that's going to introduce noise into your data. But still, the noise was like on the 2-3%, most countries that we analyzed, right? People the hypothesis will hold that most people will be speaking English or French or Italian or whatever language. And what we did is basically accept the noise. We just labeled everything that was not English as French in this example, right? And while this approach is not optimal, it did yield a lot of great results. Compared to the open source models that we had there and even the proprietary APIs, we were pretty similar, slightly better, honestly, on long documents on the social media domain, but they are very similar. Like, I think we are training in domain data, so that's kind of an unfair comparison. But they were especially better on short text, like, let's say, less than 7 words. And that was the most important part, because a lot of the social media text is very short, right? I think Twitter documents are between 7 to 11 words on average, at least when we made this analysis. And if you do that, you're creative, you can actually save millions, because those APIs, the best model that you would find this way, those APIs are very expensive, right? So multilingual, multicultural. Let me check the question. Let's see, there's a couple of different things here. Yeah, what approach would you take if it's a region of multilingual residents? Okay, yeah, that's like India was an example where we didn't use that approach. I feel that one is a bit trickier, right? Probably you need someone from that specific region, and we're going to talk about multicultural approaches here going forward. But like, you probably need someone from that specific region that can tell, oh, look, maybe not the capital, right? But those specific areas, if we can go more granular, of course, those are more likely to have this information. And what helped when I worked on this for this specific kind of situations, right, was to try to, like Canada, right, French and English, was try to, after you get this, then you might want to find just someone that can tell apart those languages. Not saying it's ideal, it's a very tricky problem. I don't think, but it's definitely approach I would do is go on the macro level, go as granular as you can later on the languages that are hard. And then if there are specific cases that you really care about to get a higher accuracy, then you probably want to invest in someone that could tell those specific languages apart or so on. Oh, there's a couple of long characters. Okay, this is about the informal language. I'll come back to this one. Matthew showed in the finally those tokens which have chain frequency is about change. Yeah. So Sam, about your question, yes, this is a great idea. Like, I feel we did the very simple approach because we did have to run this on millions and millions of documents in a very regular basis, right? So, but definitely, if you can actually use more complex models, you're going to get better results. Just going to be more complex, and sometimes it's not feasible to do that. If you're search space, and honestly, like, we did even experiment with some of those things, the gains were not as great to justify us investing in those. But definitely there were gains of doing that. That's a great idea. The accuracy of language identification. Well, no, that's the percentage of, I think you mean about the distribution of languages in Paris on my example. No, those are distributions. So we have someone to analyze like a bunch of data from Paris, and they would say like 87% of this data is French, like 11% is English, and the other ones it's neither. So just like noise or different languages, right? For the sake of time, I'm gonna move for this one, and I'm gonna go back to the context. Alok, I'm gonna go back to your question at the end. Okay. Cool. So multilingual, multicultural. Going back to the idea I mentioned, when you're labeling for English language identification, especially tricky, right? Because you need to know the languages. And as we said, to get a string in Portuguese, you might not know if you don't speak Portuguese, if that's Spanish, that's Italian, if it's Portuguese from Brazil, from Portugal. It's a very tricky problem. But that's not only true on this setting, which is extreme of the spectrum. Even if you're labeling something like sentiment analysis in multiple languages, right? It's gonna be complicated because of the consistency of annotating, right? Most people don't speak a lot of languages, so you probably cannot hire the same person to label all your data sets. And now you have to create data annotations guidelines in multiple languages for people that speak those languages, if they don't speak English as well. how do you, if you yourself that's conducting your project don't know how to speak the language, how do you know how accurate your annotation guidelines are? That's already a problem. Also, once people start, like different cultures are going to annotate the same data differently, even if you give the exact same instructions. How do you make sure that there's consistency there? Or even, do you want to have consistency if you're going to be running that in multiple like countries, right? Like if you're running something in the US and in Spain, the cultures are so different that maybe your model is being a little different depending on the language is fine. Or maybe you even want to think about training different models for different, instead of having a multilingual model. There's a lot of components that come to this. And the one I want to raise awareness to that I learned over time is the multicultural aspect. But let's think about The Office, the TV show. If you talk to someone in the UK, someone in the US, they might think about different shows. If you don't know this, The Office is two very famous shows that started with a UK version and then was adapted to US television. Completely different shows, but with the same perspective. And they were both very famous. So if you ask someone to label a data set, like the entity disambiguation project I talked about before, it definitely becomes tricky because people might not have the cultural context. And what I learned from experience as well is if you hire someone that, let's say you're hiring someone to do sentiment analysis, like I mentioned in the previous slide, and you have someone that was born and raised in the US, but their family is from Saudi Arabia and they speak Arabic. Even though that person can read your guidelines in English, they can perform sentiment analysis in Arabic, they might lack the cultural context of Saudi Arabia in general because they don't live there, they're not immersed in that culture to actually label the data properly. So yes, I'm just creating problems, not giving solutions. I'm sorry, that's what I'm going to do. The idea scenario is that you can actually hire someone from that cultural context that you're going to apply. Like if you're using that for Twitter data, for example, you want to have someone that uses Twitter on the context of being in Saudi Arabia, for example, and that person should label. Very hard. I think increasingly hard by the next things I'm going to talk about. But you definitely should be aware that all those decisions you make on who you hire to label, the way you sample your data, they are all influencing the kind of problems the kind of decisions your model gonna make, right? And as I said, that's specifically tricky because a lot of those very famous annotation tools like Mechanical Turk are very biased towards certain countries where you have majority of their annotations are coming from those countries. But if you look at the distribution of tweets, right? Well, sorry, I'm too fast on this one. So most of the focus here is going to be like people in the US, India, Canada, in England, and so on. But if you actually look at distribution of tweets in general, those languages are not the top languages. Or even if you think about the low resource languages, like the ones that don't have a lot of representation from the NLP perspective and data sets and so on, it's even harder to get data. I had this project where I worked for 2 years trying to create a 20 language sentiment analysis data set. And we just couldn't do it because we could go up to like 10 maybe, but once you start getting out of those languages that have more representations, both on NLP, but also on the labeling pool, it becomes very hard to find enough people to label the data set properly, and especially taking account all this multilingual, multicultural factor I talked about. So we basically gave up on that idea just because it is very hard to do those things on certain languages. And this is kind of call to action, honestly. Like we need to be better at doing that. We need to stop being so English focused on NLP, kind of expand at some point. But also we do need to have more people from those countries involved in NLP, so we can have multilingual projects that kind of operate among all those languages. Okay, there are some approaches, especially when you're talking about multicultural, right? You ask someone to label kind of hate speech or sentiment analysis, and those are very subjective tasks. And the labelers, annotators' beliefs are always kind of biasing those decisions. So if you hire people from different demographics or people that are immersed in different political contexts or have different beliefs, they might annotate the same data very differently. Your inter-annotator agreement might not be great, but actually that's a reflection of society, and you shouldn't throw away the data just because the annotation is not exactly how you thought it would be, or that they are not aligned. There are some approaches nowadays that actually try to, instead of sticking to a single label, actually go and try to predict the distribution of the labels, because those are more useful in practice, right? I'm not saying that's the approach that we should figure out, but that's definitely one avenue of work that we could do. But that's an open question, and I do think requires a lot more people thinking about that. So just raising awareness here. And as we approach the rest, and I want to be able to answer questions at the end, I think that's a wrap for this. Going back to the takeaways, right? If there's one thing that I hope you learn from all of this, is that communication goes well beyond the text. There's a lot of context involved in this, especially if you want to do social understanding. You need to be aware of those contextual clues, cultural clues, like who you're talking to, and so on. And systems that do operate on such dynamic settings like social media should be designed to address those challenges, or at least to mitigate them, by thinking about how you incorporate the variables, how you're going to sample your data, and so on. So I think that's all for me. I thank you so much for attending. Hopefully this was interesting to you. I hope I didn't frustrate anyone by not giving answers, but definitely I try to give answers. Those are all papers that I mentioned during the talk. If you're interested, please check them out. But I do feel that the takeaway is that it's a complex topic. We need more people working on this. And if you're interested, please submit more papers to ACL and all those conferences that address those issues. Thank you for attending.